Hello everybody, Namaskar. In the previous 5 lectures, I have discussed about the refrigerant. Refrigerant is basically the blood of a refrigeration system. Now, in this lecture, I will discuss about the condenser, which is the heat ejection device for a refrigeration system. Okay, so in this lecture, I will discuss the variety of condenser. So, the condenser heat ejection or condenser design, that is basically depending on the heat ejection ratio, which is the ratio of the heat rejection rate by the heat addition rate or the refrigeration capacity. So basically the heat ejection ratio that will tell that for unit refrigeration capacity what is the heat to be rejected from the refrigeration system. So this heat ejection ratio R can be expressed by this way, that expressed by the 1 plus 1 by COP. So if you know the COP, so we can evaluate what is the heat ejection ratio for that refrigeration system. So this heat ejection ratio is highly depending on the evaporator temperature and the condenser temperature. So for two compressor type, one is the open type compressor, other is the hermetic type compressor, and two compressors type, this figure shows that how the heat ejection ratio varies with respect to the condenser temperature and the evaporator temperature. So as shown in this figure, we can see that the heat ejection ratio will increase with the increase in condenser temperature, and that will decrease with the increase in evaporator temperature. So that means the heat ejection ratio can be increased with the increase in condenser temperature as well as the decrease in evaporator temperature, because with the increase in evaporator temperature or the decrease in condenser temperature, COP will increase, so the heat rejection will decrease. So condenser may be classified with respect to the with the defined respect, like we can classify the condenser based on the cooling media. So that cooling media may be the air or maybe the water or maybe the air and water combination. So if we use the air as a cooling media for the condenser, which is called the air cooled condenser, and if we use water as a cooling media for the condenser, so for this case that is called the water cooled condenser, and the evaporative condenser, that is basically the combination of the air cooled condenser and the water cooled condenser. So for this respect, what I want to mention that instead of water we can also use the other liquid for the condenser cooling system. So basically if you want to use the water cooled condenser or liquid cooled condenser, so we can use some liquid. Okay, so that may be water or any other liquid, and which may be connected with the cooling tower, let's say for example. So that liquid is basically absorb heat in the condenser, and that is rejected heat in the cooling tower. So in between this circuit we can use other fluid also, not only water, other liquid also we can use as a coolant. Okay, then the condenser can also be classified based on the structure of the condenser. So that may be the bare tube condenser, pin tube condenser, double tube condenser, and shell tube condenser, or plate type condenser, or shell coil condenser. So I will discuss in details each type of condenser. So let us see that what is the basic difference between the air cooled condenser. So for the air cool condenser, air is the cooling media, and this is basically used for the small systems like the household refrigerator, that for the refrigerator, that is air cool condenser, or the household air conditioner, that may be the windows air conditioner, or maybe the split air conditioner. Both the cases we will use the air cool condenser. Similarly, for the commercial applications, the freezer for the commercial applications, that is also use the air cool condenser. So in general, the air cool condenser is used for the small system, and water cool condenser, that is used for the large system. So for the water cool condenser, for the water we need some water reservoir or water resources. So that means we can use the ocean water as a as a cooling media, we can use the river water as a cooling media, or you have no water resources, then we can use the spray pond or the cooling tower to cool down the water, and we can reuse that water for the cooling purpose for the condenser. So another important difference in between the air cool condenser and water cool condenser is that for the water cool, water heat transfer coefficient is generally very high as compared to the air. So that's why the temperature difference we can maintain in case of water cool condenser, that is very less as compared to the air cool condenser. Okay, so and what I have already told, that other suitable fluid, that may be the any advanced fluid, that may be some brines, that may be some nanofluids we can use as a coolant in case of the water cool condenser. So this table basically shows that some special difference in between the air cool condenser and water cool condenser. So the first difference which I have already told, that this is the temperature difference. So what is the Tc means the condenser temperature, and T coolant, that the coolant temperature. So the temperature difference in between the refrigerant and the coolant, that temperature difference is very high in case of air cool condenser, because the very low heat transfer coefficient for the air as compared to the water. So you can see that the nearly the temperature difference we can maintain in case of water cool condenser, that is half of as compared to the air cool condenser. So and similarly in case of the volume flow rate of the coolant, so because if you use the water, so obviously that volume flow rate should be that is low for certain capacity. Okay, so for the certain capacity or certain heat rejection ratio for the condenser, the mass flow rate for the water, that will be very low as compared to the air, because the specific heat capacity of the water, that is very high as compared to the air. So similarly the heat transfer area per ton of refrigerant. So for this case also you can see that for the water cool condenser, that is very less, and that is also due to the lower higher heat transfer coefficient of the water. Okay, and phase velocity, so that is nearly same for both the cases, and other thing is that power per ton of refrigeration. So if we use for the air cool condenser, we have to use the blower, and in case of water cool condenser, we have to use the pump for the water recirculation. So for the blower capacity or the blower power consumption, that is in general higher as compared to the pump. Okay, so thermodynamically we can easily prove that the pump work should be very less as compared to the blower for same type of flow rate. And for the water cool condenser, one thing I want to mention, that we are using the velocity 2 to 3, because this velocity range is basically the optimum velocity in case of water flow rate. So for any system, water is basically corrosive. So that's why if you use the velocity lower than this, then there is a chance of corrosion, and if the velocity is higher than this, then there is a chance of erosion. Okay, so these 2 to 3 meter per second, this is in general the optimum velocity, or for some cases up to 1 meter per second also. So in general the 1 to 3 meter per second, that velocity range is basically used to avoid both the erosion and corrosion. Okay, so first of all, that water cooled condenser. So this water cooled condenser may be also natural convection type or maybe the forced convection type. So that means we can use the fan for the airflow, or fan may not be used for some cases. So for example, if you consider the condenser in case of refrigerator, okay, so for the household application, you can see that for the refrigerator, that may be the household application or commercial application, whatever may be, for the refrigerator, the back side of the refrigerator there is a condenser tubing. So for this case there is no fan is used for the airflow purpose. So that is basically the natural convection type. But if you see the condenser for the air conditioning system, so we use the fan for the airflow. So that is basically the forced convection type. So and also in time of construction, this may be bare tube type. So that for the refrigerator, this condenser is approximately most of the cases we can use simply a tubing. Okay, so there is no other thing. Sometime we can use some wire, steel wire, okay, to create to increase the heat transfer area in case of condenser. Okay, and some cases we can use simply a tubing. So and plate tube type. So for this case, tube and some we can use some plate. Okay, so plate and tube combination also we can use, and also we can use fin tube type heat exchanger. So fin tube type heat exchanger, this is widely used for the air conditioning application. So in case of air conditioning condenser, that is basically fin tube type. So here on figure is shown here. So this type of condenser, this is basically the fin tube type condenser, and this condenser is used for the air conditioning application. So the flow configuration is, this is the cross flow type. So also the depending on the flow direction of the flow of the refrigerant or flow of the air or the water, whatever the coolant we are using, so direction of flow, that heat exchanger may be parallel flow heat exchanger, or maybe the counter flow heat exchanger, or maybe the cross flow heat exchanger. So that air cooled fin tube heat exchanger is basically the cross flow type heat exchanger. Okay, so then another type condenser, that is the double, that is called the double tube condenser. So for this case, you can see that this has a two flow line. One is the in tube flow for the inner tube, another is the space in between the inner tube and outer tube, that is called the annulus space. So the annulus side, the refrigerant, we can flow the refrigerant, and for the in tube side we can use some coolant, okay, or maybe the reverse. Okay, so for this case, this flow configuration may be the counter flow type or maybe the parallel flow type. So but in this figure we can see that the counter flow type double tube heat exchanger. So the water is used as a coolant and the refrigerant is flowing in the annulus side. So this type of condenser is generally used. So this has very limited uses nowadays, but some medium type of system or medium size system, this type of condenser is generally used. Then another one is the water cooled condenser, but this is the shell tube type. heat exchanger. So for the cell tube type heat exchanger is basically we can use a large cell, and in that cell we have a number of tubes that is flowing, that is from the one side to another side. So the one fluid is flowing inside the tubes and another fluid will flow outside the tube and the inside the cell. So for this case some baffle can be used in the cell side to get the flow, zigzag flow inside the cell side, so that will improve the heat transfer in the cell side. So for this case in general the refrigerant is flowing inside the cell or the outside the tube, and in general the water is flowing inside the tube. Okay, so for this case this is basically double pass system. So in this figure there is a header for the water inlet and water outlet. So that header is basically used to distribute the water in the different tube, and then this according to this figure you can see that the water is at the inlet, the lower header of at the left hand side, and this water will distributed all the tubes half side, lower side of this heat exchanger, and that water will flowing inside the tube, and that is coming right side of this figure, and then again that water is again flow to the another tube which is at the upper half of this heat exchanger, and then the upper half of the left side of the heat exchanger, that is the outlet of the water. So water will flow inside the tube and the refrigerant will be flow outside the tube. Okay, so this type of condenser, this is generally used for the large capacity application or large application or the industrial application. So this type of condenser is used. Okay, then another type of condenser, this is called the cell coil heat exchanger type. So for this case you can see that for this case also we are using a cell, large cell, and in this large cell there is a flow of refrigerant inside this large cell, but instead of the straight tube, this similar to the case of the cell tube condenser, here we are using the spiral type, we are using the helical coil type tube. Okay, so in this tube there is a flow of water inside this tube, and outside of this tube there is a flow of refrigerant. So the refrigerant is condensed or cooled down by using the flow of water as a coolant. Okay, so this type of system may be used for some medium capacity refrigeration application. And then I am coming to the cooling tower, because the cooling tower is very that urgent or very essential component in case of water cooled condenser, because the water which is flowing to the condenser, that will be heated up, and if you want to use the water again for the condenser, so we have to cool down that water. Okay, so cool down that water, then we can again supply that water again to the condenser. So where the water is freely available, that means the river water or ocean water, for that case we can directly use the river water or ocean water in case for the condenser. But when we will use the river water and ocean water or the lake water, so for that case that water is very that is, we can say that those water is very much corrosive. So there is some corrosion problem if we use directly the ocean water or sea water. That's why the people always preferred some water recirculation system for the condenser. So for that case we need a cooling tower. So cooling tower is basically used to cool down the water which is coming from the condenser of the refrigeration system. So basically this cooling tower is connected with the condenser. So in a condenser, the water is going inside the condenser, so that water is heated up, then that hot water is coming to the cooling tower, and here that water is cooling down, and this water after cooling down, that is stored at the bottom of this cooling tower, and then that water will again use for the condenser. So for this case there is a both heat transfer and mass transfer. So basically for the cooling tower, you can see the figure that the top of the cooling tower that is open, and there is a water spraying water is spraying from the top, and in between that some filled material are there. So that means some porous structure is there, and air that will be supplied from the bottom side, and that air should be coming out from this cooling tower from the top side of this cooling tower. So when the air is flowing, so air is flowing in upward direction, and water droplet is flowing in a downward direction. So in between that, some of the water will evaporate, and the rest of the water that will be cooling down, because that will lose the latent heat of evaporation, so that will be cooling down. So for this case, the water mass that will be reduced, because some water will be evaporated in the cooling tower. So that's why you have to give continuously make up water to the cooling tower to maintain some water level in that cooling tower. Okay, so this cooling tower is used generally for the water cooled condenser and for the large system. Okay, so this is called the evaporative condenser. So evaporative condenser is widely used for the the commercial application, or you can say that the central air conditioning system for a building, or for a small market. So for this case, sometimes we will always prefer the evaporative condenser. In evaporative condenser, basically the both type of heat transfer is occurring. So one heat transfer due to the convection in between the refrigerant and air, and another heat transfer due to the evaporation of air. So in this figure you can see that at the bottom there is a water basin, and we have a water recirculation system through the pump, and the top side we are spraying the water basically, and inside the tube there is a refrigerant flow. So when the water is spraying over this system, that water droplet is coming downwards. So some of the water droplet that will be touch, or that will be sprayed on the tube. So there will be some heat transfer in between the refrigerant to the water, and this water droplet that may be evaporate at the surface of the tube. So we can also use the latent heat of evaporation, and from the bottom side air is flowing. So basically this is the there is a evaporation of the water, and also the convection in between the refrigerant and water, and also then in between the refrigerant and air. So this is on type a mixed type condenser. That means the water cooled as well as the air cooled. So the effectiveness of this type of condenser is very good, and that's why this type of condenser is preferred for the many medium scale application. Thank you.